right, so now we need to talk about some exceptions to the octet rule, because as you have realized in chemistry, anytime I give you a rule, there's almost always an exception. So for this one, we're going to look at two types of exceptions, and the first is elements that are perfectly happy with less than 8 electrons. Okay, now we're not talking about hydrogen. Hydrogen fills its valence shell. It just happens to only hold 2, not 8. We're talking about other elements besides hydrogen that are okay only having less than 8 electrons. And those two exceptions are going to be boron, which is okay with 6, and beryllium, which is okay with 4. Alright, so those are our two exceptions that are okay with less than 8 electrons. So let's take a look at boron trifluoride, BF3. So when we add up our valence electrons, boron has 3, the 3 fluorines each have 7, so that's a grand total of 24 electrons. We put our boron in the middle, we single bond our fluorines, we put our lone pairs on our fluorines, same rules as before. So we've used all 24 electrons. Now, the boron only has 6. Normally, we would share between one of the fluorines and boron and make a double bond to give the boron 8. But because it's an exception, it's okay having 3 single bonds and only having 6 electrons around it. So we're good the way it is. We don't have to double bond if boron is in the middle. And if you think about it, it has 3 valence electrons, right? It really just wants to pair up those 3 that it has. It doesn't want to get any more than that, okay? So there would be one exception, no double bonds in the boron trifluoride. Same thing with the beryllium. You could just give it 2 single bonds and it would be perfectly happy. Now, the other group of exceptions are electrons that can have more than 8 if they need to. And these are going to be any element in the 3rd period or lower. So these elements can have more than 8. They don't want to if they don't have to, but they can if they need to, okay? So when we're talking about the 3rd period or lower, looking at our periodic table, so we're talking about this period right here, so phosphorus, sulfur, and then any of those nonmetals below the 3rd period, they can have more than 8 if they need to. And the reason they can is because they have an empty d orbital that doesn't have any electrons in it. So they have space to put more than 8 electrons once they fill up their s and their p orbitals. All right, so there are 2 ways that this can happen. So here's our first example. Phosphorus pentachloride, okay? So just looking at this element, or this molecule, the phosphorus is bonded to 5 things. It's going to have 10 electrons just to be able to bond to 5 things. So that's one way that you can have more than 8 electrons is by having more than 4 single bonds around the central atom. You can actually have 5 or 6 single bonds. So if we add up our lone pair, or our valence electrons, phosphorus has 5, the 5 chlorines each have 7, so that's a total of 40. Phosphorus in the middle, 5 chlorines, lone pairs on the chlorines, and that's going to be 40 electrons with 10 around the phosphorus and 8 around each chlorine. So the phosphorus is already breaking the octet rule by having 10 single bonds, and that's one way it can happen. The other way that you can have an exception looks like this. So chlorine trifluoride, okay, if we add up our electrons here, we have 7 from the chlorine plus 3 times 7 for each of the fluorines is a grand total of 28 electrons, okay? Chlorine's by itself, so it's going to go in the middle. We're going to single bond the 3 fluorines, put our lone pairs on the fluorines, so right now we've used 24 electrons. We still have 4 more electrons that we need to put somewhere. We know we can put 2 on the chlorine, that makes 8, but we're going to have to put the other 2 on the chlorine as well. So now the chlorine has 2, 4, 6, 8, 10 electrons. It can have up to 12, but it has 3 that are in single bonds, 2, 4, 6 that are in 3 single bonds, and then 2 lone pairs, which makes the last 4 electrons. So sometimes you have more than 4 bonds. Sometimes you have 2 or 3 or 4 bonds plus lone pairs that can make more than 8 electrons around the central atom. So those would be some exceptions of octet rules. Now, these phosphorus and chlorine, these examples that I showed you, if they can only have 8, they only want 8. But if they need more than 8, and these exceptions, like I showed you, those are possible, but we don't want to give them more than 8 if we don't have to.